Hello, welcome to our video on how to operate the Seamark ZM-R750 BGA Rework station. I'll go over a few of these features before we turn the power on. It has top and bottom magnetic heat nozzles. They're just in place like this. That's our top, that's our bottom. These are spot heaters that will direct the heat on the BGA. You have a cobalt area heater there for helping to preheat larger boards. If you have large thick boards, this will heat them up and allow us to use less heat on the spot heaters. The machine will come with several different size pickup tubes. The pickup tubes have a suction cup that you will install, and you screw the pickup tubes into the pickup tube shaft. If you don't put it too tight, just snug it on there. Now put your magnetic nozzle back on. Sometimes in shipping, the emergency stop button will get depressed. So before you turn on the machine when it's first set up, make sure that your emergency stop button is released. In the box, you'll have a wireless keyboard, wireless mouse. You need to install the batteries. In the bottom of the wireless mouse is the transmitter. So remove the transmitter. It's a USB, and we can plug it into this USB port here, or we can plug it into the USB port on the computer. I usually put it down here because it's closer to the keyboard and mouse, so it makes for better response time. The machine has 5 external thermocouple inputs for monitoring your heat on your board, to track and develop profiles. Since this machine is a Windows operating system and run on software, you can do in-depth profile analysis. So first thing we're going to do is we're going to reach over here, we're going to turn on our main power switch. If the computer does not boot up right away, you'll just press the on button, the little start button here on the computer, and that'll start it up. Once the computer is started up, we want to start the ZM-R750 software by double clicking on the icon. And this will bring our operating software on the screen. The first thing we want to do, and it tells you right here, it says rating for reset. Before we can operate the machine, we have to take the mouse and click on the reset button here. And that's just going to make sure that all the motors are to home position before we start operating the machine. Down here on the machine, we have the external lighting for left and right lights. That button there. We have our top. We have our top and bottom lighting for the business system, and we have 2 buttons here, and those are to rotate your chip clockwise and counterclockwise. And we'll go over how that operates when we install when we do a chip installation. But for right now, we're going to move the camera closer to the monitor, and we're going to go over the different software controls on the monitor. Alrighty then, so let's just go over how to operate the software on this unit. I'm just going to recap. I started it over again. So the very first thing you do when you start up the software is you have to press the reset. And again, this will set everything to home position. If you don't press reset, none of the commands will work. The next thing we're going to do is we need to log in. In order to make any changes to the profiles, you have to put in a password. So if the operator is going to operate it, you can operate in this mode, but if you want to make changes to the settings, then you have to log in. So we're going to go up here to this login area where you see the NA. We're going to go to admin. What we'll do is this little screen will come up, and the password is 3/8. So I'll input 888 and press OK. And now this see everything highlights. Now we can use all these settings. So I have my system settings, I have my thermal profile settings, my manual control, recode, and authorization. Authorization is just for registration. The machine's already registered, so you won't find any use. There's no reason to use the authorization. Recording, we'll go back there later on, and this is if we want to record some of our data as it's running. Manual controls, if I click this on, this is my control screen, and this will allow me to move my cameras left, right, forward, backward, zoom in, out, and such. And I will show you more as we do the actual operation of this machine. If we click on the double arrows right here, it'll open another window, and this allows us to manually turn our vacuum on and off if we want to do manual controls. And this allows us to turn our feed position off and on, the automatic feed. And again, we'll go over this while we're operating the machine in more detail. But just to let you know, you have the extra window open there. It's controlled by the double arrow right here. So that's our manual controls. So this is if we want to operate anything manually, and as we're doing automated sequences, it will come up automatically on the screen. The next thing here is our thermal profile settings, and this is the screen where we're going to access and create profiles. So if I was going to access the profile, I would press load. And this right now I've created a generic profile for lead solder. Let's click on lead and put open. It's going to load our profile. Just letting you know the profile is loaded. We can click OK. Yes, we know. Acknowledge. So what we're going to look here is what all this means. So pen here. So you can create profiles similar to the way you would on a reflow oven. You have different zones or segments. So right, we can create up to 10 segments or 10 zones. So here our upper heater, and here's our lower heater. So my first zone is the upper heater temperature, and we're going to heat the boards up slowly, just like we would in a reflow oven. So my first segment, I'm going to bring the board up to the same temperature every time, so the profiles are repeatable. I start at 80. Once it reaches 80, we'll hold it for 30 seconds. Our rate is 1 degree per second. And reflow ovens are usually about 3 degrees per second rate or ramp. On rework stations, I usually use 1. I don't usually go faster than 3. 1 seems to be a good rate for most boards. So we have a rate of 1 second, and the rate will be the same for all zones on the top, and the rate here will be the same for all zones on the bottom. So again, we're going to go up to 80, hold it for 30 seconds, up to 190, hold it for 30 seconds, up to 220, hold it for 30 seconds, and then provided we see our solder reflow is at 250, we want to hold it at liquidus for 30 to 60 seconds. 40 is ideal. And basically I just have the same settings for the top heater, same settings for the bottom heater. So this is our profile settings for lead. If we want to add anything, if we want to add a 5th zone, like if I want to create, let's say I'm going to create a lead-free profile, then I could add another zone here. We'll do that in a minute. Let's first go over all the other settings. So over here we have our IR temperature, and IR temperature, if it's a thick board, we start at around 150. Today we're going to be working with smaller boards, and I don't really need the IR or the IR temperature. This is the area heater. That, by the way, is the cobalt area heater. So I'm just going to set this at 40 because I don't really want to use this today on our demos. And the next thing we have to do is we have to determine what is the size of our BGA. And so what I'll do is I'll get some micrometers. The BGA I'm working with today is a 35 millimeter. And so what I'll do is I'll go down here where it says BGA size, and I'll put in 35 millimeter. 35 by 35. And so when we have our BGA up in the upper nest, This will tell us how to place the BGA in the upper nest so that it's centered in the pickup tube. If you have a rectangular chip, you can put 35 by 40, 35 by 50. So you can have square chips or rectangular chips set up for this. The next thing I'm going to install is the BGA focus height. And that's the height of the BGA to stay focused in the camera. And we're going to have to do that or fine-tune that manually when we're operating the machine for the first time in the profile. But as a default, we'll start out with 10 millimeters. We have a PCB base height. So depending on your thickness of your circuit board and the thickness of your component, the distance that the pickup tube travels till it touches the top of your component is the base height. And so we want to, well, I'll go through that one. I'll go through that again in our demo. Basically, we want to set this base height so that it's about 2 millimeters more than the actual distance of the pickup tube down to the top of the component. And I'll show you how to do that in a little bit. So right now, I've got a 168 base. That's probably a good starting point. The timeout setting. This is how long you want your profile to keep recording. So if I'm doing a 7-minute profile, then 7 times 60 is 42. Yeah, about 420. Yeah, so 420 seconds. I'm just going to put my timeout setting. I usually set this at 500 to 700, depending on how long my profile is. My alarm temp, we can set that as when do we want to hear the alarm go off. And basically, I don't want to really hear the alarm go off unless it reaches a high of a temp. So this profile's 250. Maybe I want the alarm to go off at 280, just in case it goes over temp for some reason. It'll give me an alarm. And so if we have a profile that's going to be at 290, we'll maybe put our alarm at 300. So right now, we've got everything set. What we're going to do is we're going to save this. So it's just like any other Windows software you save. What do you want to save this as? We're going to save this as our lead free. I'll highlight lead. I'm going to save this as lead. I'll highlight lead. And then we'll save it. It says this already exists. Do you want to make changes? Yeah, I want to replace it because I made changes. So we're going to replace it with the new data for lead. So now we have our lead profile set. Upper heater temps. Times we're going to hold it in seconds so the board can soak the heat. Our rate, how many degrees per second it's going to heat up. Lower heater, same thing. We have our area heater temperature. And again, that's the cobalt heaters to heat the board if it's a thick board. We're not going to use that right now, so we're going to set it at 70. These area heaters can get very hot, so be careful when you're setting them above 200. You don't want them to heat up all the components on the bottom of the board. Our component size, our focus height, our base height, timeout, like say 500 to 700, and a notification alarm if we go over temp for some reason. So now, this is the profile we would use to operate for a lead board. Let's say I want to make a profile for a different board, or right now what I want to do is I want to make a profile for a lead-free board. And so when I make my profiles, I usually start out at 80, then I go, my second is 190, and I use 30-degree increments. 190 plus 30 is 220, plus 30 is 250. Let's go, I'm going to put here, 280. So we're going to go 280. We'll hold it for 40 seconds. And what I do is, as I get into the higher temperatures, I'll hold the temperature a little bit longer so the board can soak up that heat. And there's no golden rule here. This is my system. You can create your own system that works for you if you want to do something a little bit different. Everything's not in concrete, but these are just general rules for what I use for starting base profiles. So here we're going to put our bottom heater at 280. Again, 40 seconds. And 1.0. Or again, we might do 1.0, 1.0, 1.0 just so everything's uniform. So I've added another zone of heat. So we take it up from 250 to 280. And most boards are gonna, for lead-free solder, are gonna melt around 280 and up. Unless you have a really light board, you might get something to melt at 250 for lead-free. So, like I said, these are just generic starting profiles that you can build off of that I put in the machines for you. Everything else is going to stay the same. I'll keep my area heater the same. I'll keep my BGA size the same. So what are we going to do here? We've changed the profile for lead. So I want to save it, and I'm going to change the name here to lead-free. And what this will do, it'll save the new profile as lead-free. I'm going to load it just to make sure it's loaded. I'll go back here again while it's saved. And then, oops, I missed an E. So we can go back there and edit it later, but we're just going to load that in the system. Make sure it's loaded. Write complete. So we'll close this. So now our lead-free board is loaded. So it's right down here, lead-free. And we're ready to use this profile. The next thing we're going to go is we're going to go over our commands here. We have solder, remove, and mount. So if we have a component already on the board and we just want to heat it up and reflow it, we can use the solder command. So that's just going to go down, it's going to touch the component, and it's going to run the profile to heat the component up and reflow it. It's not going to remove it, it's not going to place it. The remove command is if you want to remove a component, and that will go down, heat the component up, remove it, and then place it in the upper nest all automatically. The third command is mount, and that's when we're installing a new component, and this will pick the component up from the upper nest, will align the component to the circuit board, and then it will place it and reflow it. We're going to go over all these sequences in a few minutes. For right now, for our demos, I'm going to go back to my demo profile settings. And I'm going to load. I want to pick here, I created a profile. This is a test profile with no heat. So it's just going to run a short amount of time with no heat so we can show the different operating sequences. I'll open that. It's going to load it. Write complete. What we're going to do here is I've been doing some experiments with some other chips, and since we're going to be using a 35mm chip for our demos today, I'm going to change this chip size to 35mm. BGA focus height is 9. I'm going to change that to 10. This is my default. I'm going to change the PCB base to 168. Our timeout was about 700. That way we won't know it won't time out. And we don't. This doesn't really apply, but we'll just put 250 because we're not going to be getting that hot today. Okay, so I just made a few changes for our demo profile. I'm going to save it. We're going to save it as the no heat profile. No heat, I raised this. Do I want to replace it? Yes, I do. And once it's loaded, we'll just close it and we're ready to go. Okay, so now let's get into some of the fun stuff. Our circuit board in here. Oh, one thing, your bottom nozzle here, it has a little screw on the center. So you can bring that out. What happens is, there's a knob on the right hand side of the machine, and that moves your nozzle up and down. And so say if I've got a really thin board, and the board's like sagging during heating, I can push that up a little bit and use that screw on the nozzle for board support. On the side of the machine here, you also have other board support racks, and we'll go over how to use those later. So for larger boards, we have support items. The board will normally go on the jaws here, like so. And out. So if you have boards, like this will fit boards up to about 0.100 or 120. If you get something that's too thick and it doesn't fit in the grooves, so if I get a board that's too thick and doesn't fit in the grooves, this one barely fits, or if it's an odd shape, or if I want to hold the board by the tune holes, you have hardware here. You can mount the hardware at the top here. What you can do is you can hold the board by the tuning holes, or you can hold the board by the edge. Now I'll go a little bit more how these work. But basically you have hardware that you can hold the board with if it doesn't fit inside the grooves. There's a little laser light on here. I don't know if you can see it in the video, but the laser light is just so we can get a general idea where the center of the chip that we're working with. So I'll just take it, I'm going to put my board in and line the center of the chip placement area, excuse me, with the laser light. So the next thing I'm going to do, first we're going to do a mount command. So I'm going to press mount here. And the machine will direct you what to do as you're going along. So the visual system moves out. Up here it says, I'm waiting to put the BGA on. So we're going to put the BGA on the upper plate here. We'll want to make sure our pin 1 is in the correct position for pin 1 on the board. When we install BGAs at our shop, we use a tacky flux. Some people use solder paste. I prefer tacky fluxes. I think they give a better yield and a little bit less headache to use. So right now I just got my chip in there, and I'm going to go down here. This is waiting to put BGA. There's a little box here. I'm just going to press OK. It's going to go down. It'll pick up the chip, and then it's going to go into the vision system. I'm going to zoom in a little bit here so you can see what's going on. Okay, so we showed you earlier, your control box comes up when you're ready to do the mount system. We can just do like anything else, just like with the Windows program. We can move this stuff around the way we want it with the mouse. So right here on our screen, there you can see our chips here. We have our lighting controls down here. We move this out of it. I'm going to turn my top light down. And I can adjust my light on the circuit board. So the circuit board is yellow, and the component lighting is more in blue. So for right now, I'm just going to light up the component light. So our circuit board's in gold here. That's our BGA pads. If I bring up my component lighting, I can see my nozzle in blue right here. Okay? So what we want to do is we want to line our component into the nozzle. We have micrometer adjust here, so I can just move it to the left and the right. Put my component and send it in the nozzle. I talked to you about the focus height. I'm going to use the arrows here. I want to bring my head down a little bit. What that does, that'll make my nozzle a little wider, so I get a better idea of centering the chip. Okay, so we can move our over here on the left and right. We can use the arrows to move the head up and down. We can use the Y arrows to move the vision system in and out. This moves everything around on the screen. We can move it left and right. Then we have a zoom in and zoom out. And so I'm going to zoom in a bit. And then as I zoom in, I'm going to use the arrows to move the camera to center the whole chip on the screen. And then what we'll do, we're going to adjust our lighting so that we can see the solder balls. Okay, so I'm going to explain about what I'm doing. The camera autofocuses on the circuit board, but the solder balls on the component are focused by moving the head up and down, moving the chip up and down. What happens as you move the head here up and down, the image of the solder balls will widen and narrow due to the curve of the camera. And so what you want to do, you want to adjust the head height so that my solder balls are the width of the BGA pads. So right now I've moved this up and down, and I've got my upper left corner solder ball and my upper right corner solder ball to match the upper and left pads on the circuit board. Once I've done that, I want to know what is my Z height. My Z height is 18.4. So I'm going to make a note of that. So what we're going to do is we're just going to line this up on the board. And since this is our initial setup, we're just going to place it. We're not going to run the heat profile yet because we want to go through and fine tune some settings. Right now I'm just going to go down here, I'm going to click confirm. And it's going to go down, we turn on our outer lights we want to see. It's going to place the component. And then move on to run the heat profile. But since we don't want to run the heat profile now, we're going to stop. And then we're going to go back and I'm going to show you how to adjust a few settings before we actually run this heat profile. Okay, so we went through our mount sequence. And now before we go to an actual mount and reflow, we still want to do a few settings that I talked about. Go back here. I'm going to go back here. We talked about in the first segment of the video, we talked about our thermal profile. Let's open up our thermal profile. And remember, we want to set our BGA focus height. And we also want to set our PC base height. So let's close that. Now I'm going to go open our manual control up here, our little manual control pad. I'm going to move the nozzle. I've got the chip placed on the board, and I want to find out what the distance is from here to where the pickup tube touches the top of the BGA. So over here I got up and down is your Z. So I'm going to move down with my Z. And as it moves down, you can watch your Z reading up here on the screen. Just moving it up and down, I want to see just where it touches the chip. Not where it pushes down to put the pressure, but just where the picket tube touches the top of the chip here. And that's my Z reading is 170. So what we can do, we can stop this. Oh, actually, let's just go, move it back up. Sorry, so I'm going to use my Z up. I'm going to put it back to home position, basically. And this is all using the manual controls. So I'm going to close my manual control. I'm going to go over here to my thermal profile setting again. And I'm going to set my PC base height to 170. You can set it to 170 or 172. If you're using solder paste and you want it to put a little pressure to push the balls into the paste, then you could use a little more. Say it's 170, I can set it to 172, and that'll push down on the chip a little bit so that it seats into the soldered paste. And again, if say I might have a board and the vias next to the BGA pad are not plugged and they're open, and I don't want it to push down on the chip because it'll squish all the solder down on those vias, I can set the base height so that it just barely touches the chip before the vacuum goes on, and it won't push down and squish the solder all over the place when you're removing the chip. So there's reasons to have your base height set a little bit more or a little bit lighter. Right now we're going to set it at 170. I'm comfortable with 170. I'm going to save it. And again, we're using our no heat profile, so we'll save it as the no heat. And it'll say, yes, please replace with the new settings, and close it. Okay, so now we have our base height set. Let's go back to our mount command. We'll put the chip into place. If we're doing a real chip, make sure your pin 1 is correctly located. So again, the machine tells you what to do. It's waiting for me to put the chip on, so I put the chip on here. Once the chip on, I'm going to tell it to go down here. I'm going to say, yep. I put the chip on the machine. It's in place. It's going to pick it up. I got to put my heater nozzle on. But that's okay. So we just line into the board. So, again, I have my solder balls in blue, my circuit board in gold. And by moving this up and down slowly, it'll stretch the solder ball pattern in and out until I get to match the upper left and upper right pads exactly. Now what I want to do is I want to make sure that the chip is straight up and down so I can rotate it. Use my rotating buttons. As I rotate it, I'll adjust the left-right axis. I'm looking at the vertical here. Okay, so I've got these solder balls pretty much matching the pads on the chip. And again, I want to go note my Z position is 7.21. I'm going to note that on my notepad, 7.21. I'm going to confirm and place it. don't want to run the heat profile, so I'm just going to stop. I'm going to go open up my thermal profile. And I'm going to change the focus height to 7.21. Going to save it. No heat profile. Save. Yes. Save. Good. We're good to go. Now let's put our nozzle back on. Let's go through the sequence one more time now that we're all set. Press mount. It's telling you the platform is coming out. Put the BGA on the platform. Confirm the BGA is on the platform. We'll pick it up. A little bit off rotation, so I'm going to rotate it. No, vertical. Okay, so I've got the component lined up to the circuit board. I need to fine tune the pickup. You can see it's a little bit off center on the nozzle here, so later on I'm going to go back and fine tune the pickup position so it picks up and lines square on the nozzle. But for demo purposes right now, we'll run with this. I want to zoom in and show you how the zoom works and how to line the balls with the pad a little bit closer. Okay, so here I got a little bit closer view so we can see what's going on the monitor when we're lining up the chip. So I'm using my micrometer adjustments, and I'm just going to move the board a little bit so you can see. Our solder balls are all blue, our BGA pads are gold. I can turn the lighting up and down in order to get a better contrast. With the rotation controls, I can rotate the chip clockwise, counterclockwise or clockwise. So what I do with the rotation is we'll look at our top ball here and make sure that they're all straight all the way down. We can see the bottom ball is a little bit off, so we'll just slightly move that a little bit, and then after we adjust it, we'll use the micrometer. And what I do is we'll just get this rotation adjustment so that it's vertically straight up and down. Then what we'll do is we'll just use the micrometer and we'll move the pad into the ball. So our chip, it looks pretty much aligned, but if we want to be a little more fine-tuned, and again, just so you know, this is the chip here. Just not to confuse you, the circuit board, demo board that we're using, it's a little bit larger pattern, so these gold pads out here we're not using. We're just lining the chip up to the pads that are in the chip area. So I'm going to go and zoom in. And basically what I did is I squared the chip up. I made sure that vertically we're aligned. And then what I can do is now I can zoom in a little bit. And you can see my BGA pads here, my solder ball here. So I'm not zoomed in so I can fine tune that alignment. Remember that the true image is at the center of your screen. It's in this area here. As you go out towards the edges, the images skew a little bit because of the curve of the tube. So we're focusing, when we align balls, we focus near the center. And I could use my controls and I can go all the way up here. Bring this to the center. We can see the balls are 100% on the pad. We can fine tune it if we want, just a little bit. At this time, we don't have to be that critical. So, but we're right on the pad, so let's move all the way down to the other end. And we can see we're perfectly aligned, straight up and down. So this chip's ready to go. You know, if you want to go left, right, you can go left, right. You can check your corner balls. I normally don't really go by the corner balls because those can be skewed a little bit. Normally what I like to do, I like to use the center, either vertical or horizontal centers. And again, it's all what you prefer. Now I'm going to zoom back out. Move our image back to the center of the screen. I went back and I calibrated our pickup position so the component is lined up perfectly on the nozzle. At this point, we're ready to place the chip. It's lined up. We can go complete the sequence and place the chip and reflow it to the board. Okay, so we left off our components aligned to the board. We're just going to go to our command. We're going to press confirm. Again, we can turn on our lights if we want to see what's going on here. Now, when it goes down and place the component, we want to keep an eye on when it does the release, because sometimes you get a little bit of flux on that suction cup and it'll stick, and then it'll drop the component on the board and it'll go off alignment. If you don't keep an eye on that, you can place the component off alignment. So now this will be basically, it's going to run the profile, and again, we're just doing it no heat profile, so I have a short profile, so we'll stop fast for the demo. Okay, so we're going to move on here to show you a few of the last features of the machine that you want to be aware of. So let's go up here to our system settings. And one of the things you might want to set, like I say, these are factory settings. You don't really want to change them without talking to me first. So if you do need to change something, give me a call or email. I can go over it with you. But right now, this is factory set. I don't really want the machine to go over 400°C, so we set our maximum heat setting as 400. Our time range, that's the graph here, how long of a graph that we want. If for some reason you want to have it shorter or longer, you can change this number. Right now I have the graph set for 800 seconds. If you're running a profile over 800 seconds and it cuts off and you need that data, you can turn this up, I think, to 1,000 or so. Number of samples, you won't touch that. This we don't touch it. The cooling temperature is technically what it's going to cool down to. I think the machine is factory set that all three heaters will, I think, cool down to 40°C before the fan shuts off. You don't necessarily wait till after the cool down. I usually wait till the machine cools down to below my first zone setting, which is 80°C, before I restart it. So if say normally, like I said, the machine's going to cool down to 40°C, but say I'm running some boards, it takes a long time to cool down to 40°C. So I want to cool it down to 75. Once it hits 75, I could just start the next profile, and the fans will automatically turn off when you start the next profile. So this is just more of a safety. The minimum we want it to cool down is 120, but you won't want to change that. The return, that's your rebound height. So the distance, when the pickup tube goes down and touches the BGA and then backs up, the distance between the pickup tube and the BGA while the chip is running, I call it the rebound height, and they call it the return height. Right now I have it set at 3 millimeters. If for some reason you have a tall component and you need it more, you can increase that. Your laser, the little red light that goes on the tube, if you don't want it on, you can turn it off here. I gotta use not a touch screen. So anyway, just turn it off. If you don't use the laser, you turn the laser off and on. The MES, that's if you're going to use networking capabilities. Most companies don't want to use that. Close preview, we leave that off. Once we make changes, we just save them. Save it, and it automatically saves. So I think right now we're just looking at the only thing you want to be adjusting right now is the return or rebound height. We can come back and look at that. I'm thinking, if you got the machine from the factory, you can go through and look at some of these settings I have. This one I don't change, this one I don't change, this one I don't change. I usually go with actually all these are factory set. You probably don't want to change those. It's the speed settings of your motors you might want to change. So I slow down the motors a little bit, and these are it's pretty self-explanatory. X, Y auto speed, I don't change those. But the manual speeds for the X, Y, Z, and R, I slow them down from the factory settings, especially the R is rotation. You might even want to put that down as low as 50, depending on how small of a component or how fine of a pitch. You don't touch the origin settings; those are all factory set. I'm thinking the motor speed is the only thing you might want to set. But again, if you think you want to change anything, give me a call before you change anything. Okay, so one of the last items I want to show you on this is how to hold the heat at the end of your profile in case you need more time than what you set it for. So let's do a mount. Component in the upper nest. Click go. Confirm. So right now it's going to place the component and run the profile. I go to my thermal profile. This profile I'm just running to 150, and I'm going to hold it for 20 seconds. So let's say you're running a typical lead-free profile, and your peak temperature is 290 at 60 seconds. And it looks like you're getting near the end of the profile and the solder hasn't melted. But watching the graph, you can see that the heat is still climbing. The board's still soaking up the heat, and you need more time. What you can do is you can press this constant button, and it will hold the temperature at what it's at for as long as you want. Let's wait for this to get to 150. See our temperature on the graph here, and we can see our digital form here, upper, lower, IR. My external thermocouples are not on the board right now. So we're at 150, and it's going to stop at 20 seconds. So we're going to press the constant, and it's going to hold it until I tell it to stop. So what this does is it's going to keep it on whatever temperature you just stopped it at. So if we had it at 290, it would hold it at 290. And you can watch on your graph if you have external thermocouples, if the board is still climbing in temperature. So you basically you hold that temperature until the board's absorbed all the heat. If your solder balls are still not melting, then you have to go back and readjust the profile for more heat. So this is in the case your board hasn't absorbed all the temperature, your solder hasn't melted, and then you just want to hold the heat for a little longer. You press constant. When you're ready to end the profile, turn the constant off, and give it a few seconds, and then it'll go down and end the profile.